Good evening, everyone, and welcome to session number 9 of the Amateur Radio Technician class. Certainly, I'd like to welcome everyone, including new persons who have joined, and I'd like to take this opportunity to wish the Muslim community Eid Mubarak on the occasion of Eid al-Adha, and also take the opportunity to wish everyone Happy Emancipation Day tomorrow. Looking at the curriculum, we see that we are progressing nicely through the various topics. So this is where we are in terms of the topics that we need to cover for the technician class. Last class, we looked at what a rubber duck antenna is, the shielding effect. We also looked at quarter wave, half wave, 5/8 wave ground plane antennas, as well as the half wave dipole. We considered various coaxial cable types, the RG58 and RG8, as well as air insulated hardline, also known as HELIAX. We looked at the concept of impedance, the effect of moisture in coaxial cables, UV light or ultraviolet light damage. We looked at the connectors for the ends of cabling, such as the PL259 and the N-type. We discussed what standing wave ratio was, and we stopped at page number 39. So that's where we are in respect of the no-nonsense guide. So firstly, apologies for the postponement of last week's session due to what was to be Tropical Storm Gonzalo that did the most amazing thing as far as what storms do. And the rest is history. So do apologize for the need to postpone. I'd like to congratulate all of the participants who have taken the challenge to do some practice tests. And quite frankly, yes, many persons have scored really well. And I'd like to recognize one student in particular, Sylvester, who did exceedingly well in the practice tests that has been taken. So I'd like to encourage persons to continue, use the time that you have available and try those practice tests. Again, as I said, you might be very pleasantly surprised how much you already know from what you have gone through, as well as your background knowledge. So let's look at some of the various cable types, what they look like in reality. So first off, we had talked about coaxial cable. We saw that there was an outer insulation, a copper braid, internal insulation, also known as the dielectric, and then the center conductor. That's how coaxial cable is made up, and we noticed that it was a 50 ohm type cable. We also talked about ladder line, and this is what ladder line looks like. Notice the two conductors, and it's separated by insulating material. That's how it's constructed. And if you know, if you look at it, you realize that it looks like a ladder, so hence the term ladder line. And the impedance characteristic is usually greater than 600 ohms. The bottom left here, we have the twin lead cable, and we notice the characteristic impedance is 450 ohms. So notice it's very similar to ladder line. You have the two conductors on the outside, and there's this webbing in the middle to separate an insulator. All right. And then we have open wire, which looks very much like ladder line. You notice you have the conductors parallel to each other here, and then you have these insulating pieces. So these are all feed lines. And another chart on the right-hand side showing the various feed lines as well as the characteristic impedance. And yet another diagram here showing those same cables. So various representations to show you what in practice these types of feed line or cable looks like. And remember, this is what is used to connect, for instance, your transmitter, your transceiver to your antenna, and so on. And various, we did look at this before, but just to recap, various types of meters that we use in amateur radio to measure. We have the SWR meter, we have the directional watt meter, and then we have the antenna analyzer. All instruments that we use in amateur radio business. Also, just to recap again, another device that's heavily used in the HF part of the amateur radio operation is called the antenna tuner. Remember, we said hams are matchmakers. We need to have a good match between our impedances, certainly the radio to the antenna via the feed line or the coaxial line. Sometimes we have a mismatch because the antenna is not resonant on the frequency that we want it to be, but no problem. We introduce an antenna tuner in the mix. So notice one end of the antenna tuner goes to your transmitter and the other end of your antenna tuner goes to the antenna. So it sits in between, and we have knobs that we turn around and we tune the antenna. All right, so remember, we need to always have a good impedance match or a match. Otherwise, remember what we talked about SWR, we said that if the SWR is poor, we lose a lot of that power in heat. All right, so we don't want to waste our transmitter power in heat. We want it all to go to the antenna so that we have maximum transfer of power and good efficiency. So the antenna tuner helps make the antenna look like a good match to the transmitter. So hence the term antenna tuner. Another device that we encounter in the amateur radio world is a dummy load. So the dummy load takes the place of an antenna. So it's not really an antenna, but it can take the place of an antenna. And this is used often if we want to do testing. So notice there's a big heat sink to dissipate the heat that's generated, but we connect it to our transmitter to test. So we keep the transmitter testing 1, 2, 3, but we don't want that test to go out on the actual airwaves. So we just want that transmitter power to be suppressed. And the term that we use to describe that device is a dummy load. And notice the characteristic impedance is 50 ohms. So it matches very nicely. So you have a good SWR. And notice that this is the connector that goes to your transmitter via a patch cable. All right. So this is what a dummy load might look like. So we had talked about the difference between amplitude modulation and frequency modulation, or FM. These are some characteristic curves to show you what is involved, the difference between AM and FM. And notice we are saying that AM, we have a lower quality signal and it uses less bandwidth, whereas FM, we have a higher quality signal and we use more bandwidth. But what's really the difference between the two? So we start off with a carrier. So notice for AM, this is the carrier wave, so we're transmitting on some frequency, let's say 147 megahertz, for instance. So that's the wave. But then we need to apply our voice because we want a signal to reach to the other end. So we apply our voice, and when we do that, we refer to that as modulation. So that's you applying your voice signal. And when you apply your voice signal or you modulate the carrier, this is what you end up with. So notice the two waves, the carrier and the modulation. When you bring them together, you get this at the bottom here. Notice that the carrier wave is modulated via the modulation that you see on top of here, all right? That's amplitude modulation, but there's another way that we can modulate a carrier. So again, we go over to the right-hand side and we see a carrier here. Notice the carrier, right? So again, 146 megahertz, for instance, is the frequency, or it could be any other frequency, but this is the carrier representing that frequency that we are using. All right, so we're looking to communicate and we apply our voice. So here's our voice, also called a message signal. So we start to speak, and this is our voice. And when we apply our voice to the carrier, but instead of amplitude modulation, we do frequency modulation. So notice the shifting of the frequency here, it's increasing and decreasing, right? As opposed to on the left-hand side, when we applied our modulation, notice the amplitude is what varied, right? So that's why this is amplitude modulation. On the right-hand side, notice the frequency is varying. higher frequency, lower frequency, higher frequency, and so on. So the frequency is shifting, and hence that is why that is called frequency modulation. Same carrier, same message signal or same modulation, but in the electronics, instead, we can choose between amplitude modulation to send a message, or we could use frequency modulation. And note the difference between the two. AM uses a lower bandwidth and FM uses more bandwidth. All right, so this is yet another representation of the signals, but now we are talking about a form of AM transmission called SSB, or single sideband. Now, we had looked at some of these curves before. So if this is our carrier signal here, this one, unmodulated, right? We haven't applied our voice yet to it or any signal to it, but we have a carrier here, right? So when we apply the carrier to the signal, the unmodulated carrier, we end up with a transmission where, in this case here, it's amplitude modulated. But notice you have an upper portion and a lower portion. So if we were to look here, this is a different representation of the same thing. You're seeing that we have the lower portion, we have the carrier, and then we have the upper portion. So single sideband is a technique where we remove the carrier and one of the sidebands, and we end up with just one of the sidebands. So upper sideband is where you remove the carrier and you remove the lower sideband. It's a very efficient and very bandwidth efficient means. It uses less bandwidth. Notice this upper sideband here is just using this little bit of bandwidth across here, whereas the entire AM signal was using not only this part, but also all of this. So what if we could use a technique and remove the carrier and remove the lower side, all right? We can still get our signal in, except that when it gets to the other side, the device has to introduce the carrier and all of that, but we could just send one of the sidebands and our message could get across. The quality of the signal might be less, but the message will still get across, right? So notice that we will, yes, good evening, Charlene, and welcome, right? Notice that these are all modulation techniques for efficiency and effectiveness. So we will come across single sideband or SSB. Notice it's a form of amplitude modulation. So we are doing the amplitude modulation, but we are removing a portion of the signal. All right, we either removing a lower sideband or an upper sideband. The same way you see here, we are left with the upper sideband. We could have done the opposite. We could have removed the upper sideband and end up only with the lower sideband. So it's greater power as well as more efficient or more effective use of your transmitter. So that's what we have here. It's a more efficient use of spectrum or bandwidth, and also more efficient use of power, because more of the power goes into this part rather than having to generate the carrier and generate a lower sideband, all right? There are some rules of thumb that we need to be aware of in respect of when we are using our radio. So imagine that you are a licensed amateur radio operator and you're in front of your transceiver and you're tuning the dial. Note that if you're operating below 10 megahertz, so remember that frequency chart that we had, you know, showing HF and VHF, UHF, and so on. But if we are operating below 10 megahertz, that part of the spectrum, lower sideband is conventionally used. And if we are operating above 10 megahertz, upper sideband is conventionally used. So note that. All right, and speaking of bandwidth, which is the amount of spectrum occupied by a particular signal type. So we're just showing here graphically the efficiency and how much, you know, the cost or how much bandwidth or how much spectrum is used by the different modes when we are in the various modes. So CW, also we refer to this as Morse code, you know, CW, continuous wave. It's very efficient. Look how little spectrum it uses. It only uses 150 hertz. Single sideband, on the other hand, uses much more. It uses 3000 hertz or 3 kilohertz. AM uses even more. It uses 6000 hertz or 6 kilohertz. But look at FM. FM could use anywhere between 5,000 and 15,000, right? Or 5,000 and 15,000 kilohertz, right? Or 5,000 and 50,000 hertz, which is 5 and 15 kilohertz, all right? And we also have another mode that's not shown on this graph here called fast scan TV that is using even much more, 6 megahertz, all right? So this little chart here shows you spectrum efficiency. Now we are still sending a message across, and sometimes we need to use our spectrum very efficiently. So notice the different bandwidth occupied by the different modulation types that we use: CW, SSB, AM, FM, and fast scan TV. This will come up during our questions in the question pool. You need to learn and know this, the bandwidth occupied by the various types. Speaking of CW or Morse code, right? So some of us may be already familiar with the concept of CW or Morse code. This is a chart showing the various letters and the various numbers. And there are others as well, you know. And think of this as a DIT, the dot that you're seeing, and the dash, think of it as a DA. So instead of you saying dot, dash, dash, dot, 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 think of it as DIT and a DA. But when you put them together, you get DIDA. The next one, letter B, is DA, DIDIDIT, right? So think of it like that, because that's actually what it sounds like. So try not to, you know, conceptualize it as a dot on a dash. It's a DIT and a DA. So letter E is DIT. Letter F is DIDIDA-DIT. So think of it that way, right? And hence we chose to show you the chart that shows the DITs and the DAs, you know. So just bear in mind, this is Morse code. This is what it looks like. Also, the device that is used to actually transmit Morse code is called an electronic key or Morse key. And these are two different types of keys that you will press on, and when you press, you'll beep, 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 beep. Right? So bear in mind that you use electronic keys when you need to send a Morse code signal, right? You're not using your voice, you are using a Morse code key or some other electronic means of generating these DITs and DAs. And here's a representation of how we will send Morse code. You have the electronic key. This is one type, the paddle type. It's connected to a connector on your radio. And of course, your radio is connected further to an antenna. So when you're transmitting Morse code, you're tapping the paddles to get the DITs and the DAs. The radio itself will interpret that and send the signal through out to your antenna. And that's where it goes now to the other amateur radio operator that will hear your Morse code or your CW. So we talk about phone. When we talk about amateur radio, phone, that simply means voice. Anytime you hear that we are using the phone portion of the band or we are transmitting phone, what that means is that we are speaking or we are talking or we are using voice. So we use a microphone, voice goes into the microphone is connected to the transceiver or the radio, and that radio is further connected to an antenna. So when we speak and we key the transmitter, the microphone picks up our voice, sends it through the airwaves, and the other amateur radio operator will hear us. And that is called phone or voice operation. But of course, amateur radio, we like to use fancy business. And we take a computer and connect it to our radio. So when we do that, the mode of transmission is considered digital modes. So anytime you hear a ham radio operator or an amateur say, you know, I'm operating at digital mode on HF, all that means is that he or she is using a computer typically, or some kind of computing device. Nowadays, you have so many things. You could use a tablet and a phone with Bluetooth, and sometimes even the transceiver itself has a little computer panel on the front. But once we say digital modes, it simply means that we are using a computer to connect to the radio. But we usually can either connect the computer to the radio directly if there's an interface, or if not, we need to use some sort of an interface, sometimes called the TNC, Terminal Node Controller. And the modes that we have to deal with at the technician class level is packet radio, PSK31, and JT65. So these are some of the digital modes. Think of packet radio, PSK31, JT65 as English, French, and Spanish. Just a different language of communication, right? So when you see this, don't be perturbed, packet radio, PSK31, JT65. Just think of it as being, you know, like a different language. We have here the representation of PSK, right? Phase shift keying. And how we represent that, notice that we have the wave, and notice one signal. If we change the signal, notice that the wave changes direction, or it's changing the phase. So hence, we refer to it as phase shift keying. We take the digital representation and we put it on, and we change the phase to show a different value. Some software that we use, remember I said we use a computer to connect to the radio using an interface. Well, we have to run software on that computer, no? So one of the popular pieces of software is called WSJT. That's the name of the software. And this is what it looks like. And we can use this software along with the digital modes to communicate where weak signals exist. You know, right now, remember we talked about the sunspot cycle, a previous class, and we said that right now we are at the bottom of a cycle. So propagation on HF is really bad. So if you transmit, your signal might get there, but it might get there very, very, very weakly because propagation is poor. But guess what? We can use software to dig into the noise floor and find that signal. And that software now will take the transmission and interpret it for you on your computer. So remember, digital modes, we use a computer to connect to the radio. And this is what it looks like. It pulls these signals, these weak signals out, and you can exchange or have a QSO or have a conversation. And it can be used if we're doing moon bounce. Remember, we talked about hams like to bounce off stuff. We like to bounce signals off the moon. So EME, or Earth, Moon, Earth, also called moon bounce. We can have propagation beacons to show where around the world we can communicate with each other. Remember, we talked about bouncing of signals off of meteors when they're, in the sky. We can point our antenna and bounce our signal off of it and so on. And we also have another mode. We talked about PSK31. We talked about JT65. We talked about packet radio. FT8 is another mode that uses transmissions for 15 seconds. Your computer has to have good time synchronization, but this is another mode, FT8. So that's what we can use WSJT software for, all of this. Earth, Moon, Earth, weak signal propagation, meteor scatter, FT8. We talked about packet radio. Now, this representation in the left-hand side is what a packet looks like at a very high level, the structure of a packet. In other words, it's like the building blocks of what the packet transmission looks like. And you just, for the technician class, need to know that as part of the packet structure, you have a header that contains the call sign of the station that you're communicating with. Also, as part of the packet radio structure, there's something called the checksum that is used to determine if there's an error. In other words, you have the payload, which is the actual transmission, but a checksum is calculated and sent along with the transmission, and it checks back at the other end. And if it matches, that means that the payload was correctly transmitted. So just be aware of two parts. Think of it as a sentence. You start off with a capital letter, and then you have some other letters and some words, and then you have some punctuation and then a full stop. So think of this as this start here as your capital letter, and think of this end here as the full stop. So you have content in between, right? And two things that you need to be aware of that's inside of a packet radio packet is the header with the call sign and the checksum. Also, bear in mind that as we are sending these digital transmissions across the airwaves, remember sometimes, it gets lost. It might not reach, it might reach halfway and so on. And if it does that, there is something called ARQ, automatic repeat request. So the receiver on the other side might say, but wait a minute, I did not get that transmission, So the sender says, you know what? I am going to retransmit that packet to you because maybe it wasn't received. So you just need to be aware of the concept of ARQ, or automatic repeat request, that will resend the transmission or the signal that was not received due to probably poor propagation or multipart or some sort of distortion that caused it not to be received. Also in amateur radio, we can, just like you have GPS tracking for your cars, you want to see where your fleet of vehicles are, or you're concerned about where your car is, in this day and age, we have car search and we have all these other GPS trackers. Well, amateur radio, guess what? We use GPS as well to perform tracking our own, right? So You can have a transceiver or handheld radio like this on the right-hand side that contains a GPS receiver at the top, and you can transmit packets out of it. It will be received by a station that is operating an internet gateway, for instance, and it will send your location to a map so you can track to see, where you are on the earth. So if it is that you're interested, you can go to this website, aprs.fi, and move around the website, and you will see a lot of stuff being tracked via GPS and via amateur radio. So just be aware that there's a facility called APRS, which means Automatic Packet Reporting System. Some people incorrectly say the P means position, but it's really Automatic Packet Reporting System, where GPS can be used in conjunction with a radio to send your location and have it displayed on a map or on another transceiver that has the capability of showing the APRS. So just bear in mind that hams also use radio in this way. It's a good way, you're on a project, for instance, well, React, we'll do a lot of road races, and we often report on the front door or the front of the race is located at the corner of street X and Y. Well, we can have a radio do that for us all automatically by receiving the GPS lat and long, sending it through the transmitter to a receiver that will populate it on a map. So Automatic Packet Reporting System, APRS. Again, yet another digital mode when we talk. So remember, we talked about using voice. Most often we have been using analog voice, AM and FM, those are analog modes. But we can also use digital modes. And guess what the most popular digital mode is called? It's called digital mode mobile radio, DMR. And DMR, it multiplexes, or it takes two voice signals and puts it on the same frequency. Imagine that on the same frequency, you could have two conversations going to a repeater and so on simultaneously, right? So DMR facilitates that using something called time division multiple access, or TDMA. It does it by using slots. So it's the same frequency, but it's slot one and then slot two, then slot one, then slot two, and so on. So it time divides that signal, and therefore that allows for two transmissions to appear to be taking place simultaneously on the same frequency. So we say multiplexing two voice signals, and it's a 12.5 kilohertz repeater frequency. We also have the concept of talk groups for DMR, just like channels, those of you who are familiar with Zello, you go on a channel, or you have a trunk radio, you're on a channel, or even your television, you use a channel, your cable TV on a channel. Well, in radio world, we call those talk groups. So we go into a particular talk group, which is really a virtual voice channel. We can share the frequency or we can share the channel, but it's virtual, and only persons on that particular talk group will hear each other. If you're on a different talk group, unless you're on scan, you will not hear someone else on a different talk group. So they are really separate groups, and they won't hear each other normally. Again, the exception is if you have scan on, or what is called promiscuous mode on your radio, you wouldn't hear anybody else. And notice that to talk on the talk group, you need to join that group ID. Yet again, amateur radio operators love to repurpose equipment. So you may recognize these as wireless routers. Yes, ham radio operators will take those wireless routers, repurpose it because we have license for parts of the spectrum, and put special firmware on them, and then create what is called a mesh network, very high speed sort of internet connection using these wireless routers. And these routers could be located within a township or a city, or even across a country. And we can have high speed internet access using repurposed commercial gear. Using Wi-Fi, 2 and 5 gigahertz, we can use the commercial Wi-Fi gear. This, for example, these are Linksys routers, but Ubiquiti routers are also used. A modified firmware is put onto the router, not the one that came with it, that will allow amateur radio operators to use a higher power and wider part of the spectrum and the bandwidth given the licenses that we have. And two of the most popular mesh networks that amateur radio operators use are called broadband hamnet. It used to be called HSMM, high-speed multimedia, and amateur radio emergency data network. So those are the two most popular forms of mesh networks. And notice that the routers talk to multiple routers depending on where they are. So notice this router here cannot see this one, so therefore they cannot talk, but they can talk to each other through an intermediary. Hence the reason we call this a mesh network. So at this time, we will take a 2-minute break. So get some water, have a bathroom break, take a stretch, and we'll be back. Okay, welcome back, everyone. So let's pick up where we left off in respect of the no nonsense guide. We stopped at page 39. So let's continue. The next question in the question pool. Remember we talked about SWR last class, so let's just finish up some of these questions. Why do most solid-state amateur radio transmitters reduce output power as SWR increases? Remember, a high SWR is not a good thing. We said it could generate a lot of heat and could even damage equipment. So the answer is, the reason why the transceivers or the transmitters reduce output power with a high SWR is to protect the output amplifier transistors. Those transistors are very expensive, and if they overheat for too long, well, they can be destroyed. Next question in the question pool. What instrument other than an SWR meter could you use to determine if a feed line and antenna are properly matched? Well, we looked at it during the slide deck. A directional watt meter is the other instrument that you can use. Next question. Which of the following instruments can be used to determine if an antenna is resonant at the desired operating frequency? Well, we looked at 3 instruments during the slide deck. Well, the antenna analyzer is the instrument that does just that. You simply connect it to the antenna and it will tell you where that antenna is resonant or where that antenna is matched or what frequency the antenna is cut for. Antenna analyzer. Next question. What is the major function of an antenna tuner? So remember that in the slide deck, we looked at what an antenna tuner was. We saw that on one side, we have the transmitter, and the other side, we had the antenna. The answer is it matches the antenna system's impedance to the transceiver's output impedance. All right? And we said hams are matchmakers. Next question in the question pool. What is the primary purpose of a dummy load? We talked about it. We said that it's used to prevent transmitting signals over the air when making tests. All right, so remember, it doesn't propagate into space. It just stays right there and dissipates in heat. And we testing, 1, 2, 3, 9 Zulu 4 Omega Golf testing, right? So that we don't want that going over the air. We just want to test our transceiver. We use a dummy load. It doesn't transmit out beyond probably our immediate vicinity. What does a dummy load consist of? All right, well, the theory here tells us what it is, right? Basically, a dummy load is just a big 50 ohm resistor. Well, that will be the answer. A non-inductive resistor and a heat sink, right? The heat sink is so that it could dissipate the heat. If we didn't have the heat sink, it might melt, right? So that's what a dummy load is consisting of, a resistor with a heat sink. Okay, so we enter the section here on amateur radio signals, modulation modes, and signal bandwidth. All right. So for the technician class, we just need to know that FM is the modulation that we are likely to use first in the technician class, because for the technician, only privileges are granted in the VHF and UHF parts of the spectrum and above. HF privileges is not typically granted to the technician. There are some little exceptions and so on, CW portion of the band, but that's why FM is what is mainly used by technician class operators. Question in question pool. What type of modulation is most commonly used for VHF and UHF voice repeaters? The answer is FM modulation. Similar question. What type of modulation is most commonly used for VHF packet radio transmission? Again, FM. Simply need to learn that. But just bear in mind that you use FM as a technician class operator, right? All right. We dealt with the theory in the slide deck, so we'll move straight to the question in the question pool. Which of the following is a form of amplitude modulation? Remember when we showed the diagram of the amplitude modulated signal and we chopped off piece and we said that single sideband, but it starts with an AM or amplitude modulation based signal, right? So which of the following is a form of amplitude modulation? The answer is single sideband. The distractors will tell you all sorts of FM and all sorts of C4 FM and all sorts of other distractors. But you know that SSB or single sideband is a form of AM or amplitude modulation. Okay, which type of voice mode is most often used for long distance weak signal contacts on the VHF and UHF band? Remember we said that single sideband is very power efficient and spectrum efficient and so on. We can use more of the power in terms of driving the signal. So if we have a long distance contact to make and it's weak, we tend to use single sideband or SSB. So notice how they're mixing it up here. They're calling it single sideband up here and they're calling it SSB here. One and the same thing, single sideband. Here's a little bit of a trick question. Where may SSB phone be used in amateur bands over 50 megahertz? So you see how they're trying to, ask a very sophisticated way, a simple question. SSB phone. Remember we said in this slide deck that phone really means voice. So don't get tied up when they ask the questions in this way. When may SSB, single sideband, voice or phone be used in the amateur bands above 50 megahertz? Well, the reality is that you can use that in at least some portion of all of these bands. So all of these bands, there's an allocation in the band plan for you to be able to use SSB. So is in at least some portion of all of these bands above 50 megahertz. So you just need to learn that. So they make the point here that a single sideband signal may be either USB, upper sideband, or lower sideband. Remember when we looked at the amplitude modulated signal and we said we could chop off the carrier and chop off one of the sidebands, right? So if we chop off one, the lower side, it will be the upper side that's left. And if we chop off the upper side, it's the lower side that's left. Which sideband is normally used for 10 meter HF, VHF, UHF single sideband communications? So notice this is above 10 megahertz, right? Remember we said below 10 megahertz, it's lower sideband, and anything above 10 megahertz is usually upper sideband. So that's how this answer is derived. Because all of these frequencies that they talk about here, 10 meter HF, VHF, UHF, is above the 10 megahertz frequency, right? 10 meter HF is 28 megahertz, VHF is 144 to 148, and UHF is in the 400 megahertz band. So all of this is above 10 megahertz. And what we said in the slide deck, anything below 10 megahertz, it's lower sideband or LSB, and anything above 10 megahertz frequency, the modulation when you're using sideband is upper sideband. So that's how they get this answer. Right? Remember we said that the FM signal is better quality than AM, but FM occupies a wider bandwidth. They're just repeating that here. What is the advantage, or what is an advantage of single sideband over FM for voice transmission? Right? So remember we said that AM, or which is what single sideband is based on, uses less bandwidth. Well, that's the answer. SSB or single sideband signals have narrower bandwidth. Right? Next question. We dealt with this in the slide deck. So if you need a refresher, you can just take a look at the slide deck. What is the approximate bandwidth of a single sideband SSB voice signal? The answer from that table that we looked at is 3 kilohertz. So you just need to learn that. Related question, what is the approximate bandwidth of a VHF repeater FM phone signal? So the emphasis here, keywords, FM. Remember we had a range of frequencies for FM that it could occupy, or a range of bandwidth. Need to learn it. Between 10 and 15 kilohertz. So the distractor questions will put all sorts of other numbers for you, but you need to know it's between 10 and 15 kilohertz. And notice we said some modes have very wide bandwidths. Remember we talked about fast scan TV? Anyone remembers how much bandwidth it occupies? Well, we'll see it now in the question pool. What is the typical bandwidth of analog fast scan TV transmissions on the 70 centimeter band? Well, we said for fast scan TV, it uses 6 megahertz or about 6 megahertz. So you probably did not know that amateur radio operators transmit fast scan TV, yeah? Yes, you thought it was voice only? No. All sorts of modes. You'll be quite surprised as to all of the things that amateur radio operators do. Remember, we have a lot of spectrum and we love to experiment. Matter of fact, a license for amateur radio is a license to experiment. What type of transmission is indicated by the term NTSC? So you may already be familiar with this and say, wait, that's the standard of television transmission. You may already be familiar. It simply means National Television Standards Committee. That's what NTSC is. So once you see NTSC, you know it has to do with television. So the answer to the question is an analog fast scan color television signal. Coming back to, remember the slide deck, we showed all of the various modulation schemes, how much each one occupies. Here's a question. Which of the following types of emission, right, has the narrowest bandwidth? So don't worry that they're using very sophisticated terms in the questions, that they're just trying to tie you up. Emission, think of it as transmission, right? Which of the following types of emission has the narrowest bandwidth? Remember we saw that CW was very, very narrow. Well, the next question actually asks how much or what's the bandwidth. So let's save that for the next question. So just note the narrowest bandwidth, CW. That's the mode, continuous wave, right? And what do we use with CW? Morse code, right? Cool. Moving right along. What is the approximate maximum bandwidth required to transmit a CW signal? Remember that table, that little diagram? It was only 150 hertz, very, very little part, very, very tiny, itty bitty piece of the spectrum, 150 hertz. All right. Well, we gave this one away just a while ago. What code is used when sending CW in the amateur band? Well, we said that we use Morse code. So the answer is International Morse. What is an electronic keyer? We did show on the slide deck what it looks like, or a couple of versions of what it looks like, an electronic keyer. It is used as a device that assists in manual sending of Morse code. So once you hear electronic keyer, you know that is used to send Morse code. All right. So digital modes, packet. So we talked about PSK 31. We talked about the various modes. So let's go straight into the question pool. Which of the following is a digital communication mode? Remember we said anytime you hear digital communications, think of a computer connected to a radio. All right, so the answers are packet radio, IEEE 802.11 and JT65. So you just need to learn that these are the digital communication modes that are used. All right, so just learn this off. But right away, you get the sense watching this, it's somehow computer related. So that should be the aid to memoir. Once you talk digital communication modes, you're usually talking about a computer connected to a radio. Right. Remember we talked about packet radio in the slide deck. Let's go straight to the question and the question pool. Which of the following may be included in packet transmissions? So we said, if you remember the little sentence that we showed what a packet looks like, and we said, you know, it starts with something, has something in the middle, and it has an end. We showed that a checksum is included in that packet. And the purpose of the checksum is for error detection. We also said that there was a header that contains a call sign. And we also had said that there was something called the ARQ in case there's an error. So all three of these answers are correct for this question. What's included in a packet transmission? So again, something you simply need to learn. Right, so this question now asks us, what exactly is ARQ? So let's read this out. Matter of fact, let's just deal with this piece of the theory here. Some amateur radio digital communication systems use protocols which ensure error-free communications, right? One such system is called an automatic repeat request, or ARQ. right? So what is an ARQ transmission? Let's see what they give us as the answer. It's a digital scheme whereby the receiving station detects errors and sends a request to the sending station to retransmit the information. So that is what ARQ is. It didn't get the signal properly. It's like, this looks kind of suspect. The checksum didn't add up or something like that. Send me back, please. That is basically what ARQ is. We also talked about what APRS is. So what does the term APRS mean? Automatic Packet Reporting System. Remember we showed the diagram with the radio, with the GPS and sending the latitude, longitude, and you displaying your position on a map? Well, think of APRS as GPS tracking for amateur radio. Which of the following is an application of APRS? Providing real-time tactical digital communications in conjunction with a map showing the locations of stations. That is just a sophisticated way of saying what we just said. APRS is GPS tracking of amateur radio. Next question. Which of the following devices is used to provide data to a transmitter when sending automatic position reports from a mobile amateur radio station? Well, you have to have something giving it location. What is that thing called that gives the location? We should all be familiar with it. GPS. GPS is Global Positioning System Receiver. So whereas it could be built into the radio, as we saw in the slide deck, the radio had a built-in GPS receiver. If your radio doesn't have a built-in one and has a interface, you can put a GPS receiver connected to the radio, and there you go. So you need to have a global positioning system, which is what GPS means, receiver. What does the abbreviation PSK mean? Again, in the slide deck, we alluded to it. It means phase shift keying. And we saw that was when you had the cycle and then you change the shift to indicate a different value. So that is what PSK means, phase shift keying. Simply need to learn that. All right. We also dealt with this in this slide deck. Which of the following best describes DMR, or digital mobile radio? The answer is a technique for time division multiplexing or time multiplexing two digital voice signals on a single 12.5 kilohertz repeater channel. If you look back at the slide, you will see all of this information is actually what is indicated on that slide. It's time division multiplexing or time multiplexing. It's two voice signals on a single 12.5 kilohertz repeater channel. Right? So imagine that, two conversations simultaneously going on the same frequency. Cool, eh? All right. We also talked about talk groups. What is a talk group on a DMR digital repeater? What is a talk group? It's a way for groups of users to share a channel at different times without being heard by other users on a channel. You know, it's like a private channel, right? Separate from other channels, which you can switch to get there. So that's what a talk group is. And how do you join a digital repeater's talk group? Well, you program your radio with the group ID or code. So if you're on talk group 969, which is actually the DV Caribbean talk group on DMR, those of you who are already amateur radio operators in the class and are already doing DMR, you may be familiar with talk group 969. Right, so you just have to program your radio with that talk group and you join the talk group. Without it, you cannot join and you cannot listen to the transmissions. We talked about the WSJT software suite. Let's go straight to the question. Which of the following operating activities is supported by digital mode software in the WSJT suite? So we listed them in the slide deck. Moon bounce or EME is one. Weak signal propagation beacons, another, and meteor scatter. So they say all of these choices are correct. And we also said that FT8 is another mode that you can use with the WSJT software. So What is FT8? We talked a little bit about it. We did say it transmits in 50 seconds interval, and we also said it's weak signal propagation mode. So the correct answer, what is FT8? FT8 is a digital mode capable of operating in low signal to noise conditions that transmits on a 15 seconds interval. So let's pause a little bit and dissect this answer a little bit. Because we have the theory on slides, but you might be saying to yourself, but how do we get this answer from those slides? Well, let's dissect this answer a little bit. What is FT8? Now we're using WSJT software, right? That means we have a computer. So therefore it's a digital mode. Once we said we're using a computer connected to an interface to a radio, it's a digital mode. That's what we said digital modes are, using a computer. So a digital mode. See how we get that? Digital mode, because it's using a computer with software. It's capable of operating in low signal to noise conditions. You remember say weak signal? It's a weak signal propagation mode. That's how they get low signal to noise condition. All right. That transmits on a 15-second interval. We said that the computer that is being used needs to be properly time synced to be able to be used, and it's 15-second transmissions. So that's how they get transmits on a 15-second interval. So you see how they sort of, make it sound a little more sophisticated and more difficult than it might need to be. But once you dissect it and make the relationships, you will be able to get through with the understanding of it. So just dissect it and don't let them, spin you around too much with how they put things. All right, we talked about mesh networks. So let's go straight into the question. Which of the following best describes broadband hamnet? And they put TM meaning trademark, also referred to as high-speed multimedia network, or HSMM. Right? So which of the following best describes that? The answer is it's an amateur radio-based data network using commercial Wi-Fi gear with modified firmware. So let's dissect that answer a little bit. So remember we showed you the diagram, you saw the Linksys routers, you saw how some of them were communicating with others and they could route the signal between them easily. Even though one router may not be able to see another, it can go through another router and get the signal there. So let's dissect this. It's an amateur radio-based data network. So you must have an amateur radio license to use the higher power that's required, as well as that part of the extended spectrum. So it's amateur radio based. It's a data network because you'll have to plug a computer in to use it. It's not a voice or radio network. It's a data network because notice it's the Linksys routers or the Ubiquiti routers. And what do you connect to routers? Computers. All right. So you don't connect a radio usually directly to that. So it's a data network. Think of that as internet or some sort of networking. And it uses commercial Wi-Fi gear. Well, Linksys routers or Cisco routers or Ubiquiti routers, those are commercial Wi-Fi routers. So that's what this simply means, using commercial Wi-Fi gear with modified firmware. Well, we did say you have to change the firmware inside of those routers to be able to get it to do this manipulation with the mesh network. All right, so that's the answer. All right. So, folks, that is essentially what we did with the slide deck. We will stop here. It's almost 9:30. We will pick up electrical safety in the next class. So again, I would like to say thank you so much for your time and patience as we deal with the amateur radio technician class material. Thank you very much for sticking to it and having gotten this far. I'd like to encourage persons to continue your efforts at attempting the practice tests, the exams. We will be sending out the invitation to the next class as well as our slides from this class very shortly. Our next class is scheduled to take place on Friday, the 7th of August. So folks, given what's happening with COVID-19 and what we're seeing in terms of the spread and all of that, local spread, please be safe out there. Your health is important and please take all necessary precautions. We want to have you, each and every one of you, for a very long time. So let's all heed the advice. of the authorities. So folks, continue to monitor the weather out there. Be safe. Do have a great weekend. Enjoy the holiday, and hopefully see you for our next class on the 7th of August. Thanks so much, everyone. Do have a good night and God bless.